The next part of the podcast is about the uses of radiation. So radiation can have plenty of uses, and so we'll just go over a couple of them. Sometimes you might be asked to describe a couple of them. One here is for sterilisation purposes. If you have a gamma source will give you out gamma rays. It can be used to kill bacteria, mould and insects in food. This can be done even after the food has been packaged. It can affect the taste, but supermarkets like it because it lengthens the shelf life. Now that's not dangerous to you because once the radiation has been killed, you won't feel it. The radiation has already passed through it, and you won't have any effect of that. Gamma rays are also used to kill bacteria on hospital equipment. It is particularly useful with plastic equipment that would be damaged by heat sterilisation. And so you can see there your tomatoes gone through the gamma source, and once they've gone through, then they've been sterilised and they're quite safe. Gamma rays also to kill bacteria in hospital equipment. The heat could damage them, and so it's really good if you can use gamma rays on them, and you know when you're taking them out of the packet that they're completely sterilised and safe to use. Another example is radiotherapy, and I might scan in a wee bit here just for you so you can read this. A carefully controlled beam of gamma rays can be used to kill cancer cells. It must be directed carefully to minimise damage to normal cells. However, some damage is unavoidable, and this can make the patient ill. So sometimes people will have side effects of things like radiotherapy or chemotherapies with drugs. But radiotherapy is when you blast the cancer tumour with radiation. It is therefore a balancing act, getting the dose high enough to kill the cancer cells, but as low as possible to minimise the harm to the patient. And so even though radiation can kill cells or damage cells, it can also be used to kill cancer cells, which is very good, provided you get it right. This is a quite common one now. This is detecting leaks in pipes. If, say, you've got a water pipe or some kind of pipe under the ground, and it's very difficult to dig it up and to check where the leak is, what they can do is they can run a detector tube along the top of the ground, and they can put a liquid through the tube or the water, whatever it is, and put what we call a tracer. And a tracer contains a radioactive material which gives out gamma rays. And you can detect the gamma rays, and obviously over the source of the leak, you're going to detect far more gamma rays at that particular place. And very quickly, without having to dig up the ground in lots of areas, engineers can tell almost immediately, right, that's where the source of the leak is. Now, obviously, that would have to, the tracer would have to be in the pipe for a very short period of time, otherwise it could contaminate water supplies or whatever the pipe is carrying. So just read through this. The radioactive isotope is injected into the pipe. Then the outside of the pipe is checked with a Geiger-Müller detector or some kind of detector to find areas of high radioactivity. These are points where the pipe is leaking. This is useful for underground pipes that are hard to get near and you don't want to dig up the whole area. The isotope must have a short half-life so the material does not become a long-term problem. Obviously, if it was a water supply, you wouldn't want radioactivity still in your water by the time you were drinking it. The radioactive isotope must be a gamma emitter so that it can be detected through the metal. And if this is up on the surface, say if I just drew this up here, if that was the surface and your detector was up here, your radiation has to get up right through the pipe and up through the soil. So alpha or beta are no good. They would be blocked by the metal and the earth. And so if they ask why gamma is suitable, that's one of the reasons. Make sure you say that alpha or beta are not suitable because they'd be blocked by the metal and the earth. Another thing is for where you have a machine which is rolling out sheets of something. Now it could be paper, it could be aluminium, it could be anything. But what you can do to check the thickness of the sheets is if you have your rollers set at a certain distance and they're rolling out there, you can see here this is thicker than this part here. What you can do is allow your material to pass through, roll it so it gets thinner. If you have a beta source in a detector, it should always be detecting a constant count rate if the radiation is coming through. And if it is thicker, then it should have a lowered count rate down here, and that means that you have to adjust the width of your rollers, the width that the rollers are squeezing this out into. So just to read through it, a radioactive source is in one side of the detector, one side of the material, and a detector on the other. If too much radiation is getting through, then the material is too thin, and the rollers must be opened up a little bit to make the material thicker. If not enough radioactivity is detected, then the rollers compress to make the material a bit thinner, so these are pushed closer together. This method is used in the manufacture of lots of sheet materials such as plastics, paper and sheet steel. And this is just a question which is already answered. Which one of the following is not a use of radiation? And the answer is prenatal scans, in other words scans with the unborn baby. And the reason is because the unborn baby is very sensitive to radiation and it could damage it physically, and it could be born handicapped. So that's why they never use any kind of radiation, either gamma rays or indeed X-rays. Radiotherapy it's used for to treat cancer. It is used in smoke detectors, where you have a smoke detector. There's a wee detector here and some kind of source, and you have your detector always detecting the radiation come from the source. But if smoke comes in between that, if you have smoke in between it, then it won't be detecting the same amount of radiation and the alarm will go off. And it is of course also used for detecting leaks.